Okay, so we are going to look at two-way problem. This is an interesting problem asked in interviews. Basically, like, it doesn't test programming as such, but it tests your mathematical abilities and logic. Okay, so the problem statement is as follows: a building has 100 floors. Out of these 100 floors, one of the floors is the highest floor from which an egg can be dropped from without breaking. So egg won't break if you drop from this highest floor. Okay. So let's say if this highest floor is x. Okay. If you drop from x plus 1 floor, it will break. However, if you drop from x or less than x, right, then egg will not break. So you have to find this x. And thing is, and when you drop from x or below x, okay, the egg is undamaged and you can drop the egg again. Okay, so that's how you need to find out, like, what is the highest floor from which an egg can be dropped without breaking. Okay, now let's say so the problem is as follows now. Alright, so so you are given 2x. So for you to solve this, you are given 2x, and you need to find the highest floor from which an egg can be dropped without breaking. Okay, this is a catch: with as few drops as possible. Okay, what he is saying is as few drops as possible. Okay, it's not like, you drop from first floor, second floor, third floor and keep on doing, and you come to 100th floor and you say, like, okay, it will not break, it will break at, let's say, 99th floor, something like that. And if you do like this, then it's almost like, okay, you are doing 100 drops. This is not the optimal solution. I mean, this is not the fewest drops, right? So you need to figure it out, like, as in as few drops as possible. Okay, so pause for a few minutes and think of a solution. Okay. Okay, so let's break down this problem. Okay, what exactly this is telling. Okay, let's say, so your building is like what, 100 floors, right? That's what he's telling, right? So it's a 100 floor building, right? Okay, 100 floors building, 100 floors, right? Now let's say you have only one egg. Then how do you solve it? Then you don't have any other option, right? You have to play it safe. So you start from the bottom, you working your way up, drop the egg from every floor, and then you figure it out what is the highest floor at which it doesn't break. So you go from first floor, second floor, third floor. Okay, you keep going. Let's say at 75th floor, egg breaks. Let's say if it breaks, then you come and say, like, okay, 74th floor is the highest floor at which egg will not break. This is how you will tell, right? But here, in the worst case, what will happen is you will end up dropping the egg 100 times. Let's say your egg drops at your egg doesn't break at 99th floor, but to test to figure it out 99th floor, then you have to drop till 100th floor, and then only you figure it out, like, okay, you go from 1, 2 up to 100th floor, and it breaks here. Then you come and tell, like, okay, 99th floor is 99th floor is where it will not break. Okay. So this is like you end up, in a worst case, you end up dropping 100 times. So this is not the optimal solution. Okay. So but this is the solution you will use when you have only one egg. Alright. But here we need to think differently because we have two eggs, right? So we have to think differently. We have to do things differently. So how do we do that? Now here, see, you have two eggs, so we can do things differently. So what do you mean by doing differently? So you start with first egg, okay? You keep going, and when you figure it out, like at some place, if egg breaks, okay, you keep track of like, okay, what is the last time egg doesn't break, and between this and this you keep trying with the second egg. Okay, so that's how you can try. So you have two eggs, we can skip multiple floors at a time until the first egg breaks. And okay, the thing is you need to keep track of, okay, what are the floors we are dropping from. Okay, the first egg. So let's say we drop from first floor. Okay, let's see that. Once the first egg breaks, we can use the second egg to try every floor starting from the last floor where the egg didn't break and ending on the floor where it did break. Okay, so let's see with an example here. Okay, let's go it with an example here. Okay, right. So let's go it with an example. Okay. So here, right. So first egg we start. Then we drop it from the first floor. Then we skip to 5th floor. Then we skip to, let's say, we skip to 6th floor. Then we go to 13th floor. Then to 22nd. Let's say if your egg breaks at 22nd floor, okay, it breaks. The first egg, right? So the first egg breaks. Now you have your second egg, and you know that at 13th floor it didn't break. So you start from 14, 15, 16. So like that you go. And when you find that, okay, 19th floor if it breaks, then you come and say, okay, 18th egg is where it did not break. Okay, this is how you can figure it out. But now we don't know what is the optimal way to skip these floors. So we don't know. We just came random numbers here. But how many floors we should skip when dropping the first egg? This is a question to us, right? So how do we know that? Okay. So there are multiple approaches to solve that problem. Okay. So okay, now thing is, the option 1 is a binary approach, let's say. Okay, this is a binary approach. So what happens in the binary approach is, you know, right, what is a binary search or binary approach? We keep dividing the problem in halves, okay? No, not this way. We keep dividing the problem in halves, okay? We divide the problem, okay, and then we divide it again, then we divide again, then we divide. So that's how we solve in the binary solution approach. So in the binary approach, we drop first egg halfway up the building at the 50th floor. Okay, if it doesn't break, let's say, then we go to, so at 50th. So this is the thing, right? So at 50th floor we drop. If it doesn't, if it is safe, then we go to 75th floor. Okay, let's say at 75th floor if it breaks, then we have to go from 51 till 74. We have to go one by one, right? So let's say if it doesn't break at 75th floor also, then we keep going like this, dividing the problem half at each step. Okay. Okay, when the first egg breaks, we use the second egg on our range of possible values. So let's say here, right, we started with 50th floor, it didn't break, it is safe. We divide the problem again, we go to 75th floor, and let's say if it breaks here. So your first egg breaks here, then using your second egg we go to this range, okay, and we figure it out what is the safest floor, okay, what is the highest floor where egg cannot break. So that is how. So your range is like the last floor where egg did break and the floor where egg did break. So between this is your range. So that is how we can go with this approach. But in the worst case, what will happen with this approach is, let's say if your floor is like your first egg breaks at the 50th floor. Okay, so you started like this. This is your first floor, and let's say this is your 100th floor, and you are starting from here, and this is your 50th floor. Let's say, right? Okay, this is your 50th floor where you are trying. Okay, if it breaks here, if it breaks at the 50th floor, then you have to go from 1 till 49, right? To figure it out which is the thing. So you are almost doing like 49 drops, and plus 50th drop is, so almost you are doing 50 drops. Okay, in the worst case. Okay, so your highest floor is 48th floor, let's say, Since first egg already broke, you don't have any other. So you will have to drop second egg from every floor from 1 to 49. Why you have to go till 49 even if the highest floor is? Because you don't know whether 49 it will break or not, right? Okay, because your first egg broke at 50th floor. So you are not sure whether it is 48 or 49. So you have to go till 49, and if it breaks here, then you come and say 48 is your highest floor. So you have to do 50 drops here. Okay. So can we do better than the binary approach? See, binary approach in a worst case we are ending up doing 50 drops. So can we do better than this binary approach? Okay, let's say instead of doing binary approach, we skip one by one. Let's say, okay, we start with 1, okay, and then we go to the third floor, okay, then 5th, then 7th, like that. We skip one floor, okay, at each time, okay. We end up going like that, okay. So what will happen is, let's see the worst case scenario. Let's say the worst case scenario, the highest floor is 98, okay. Then you end up doing, you skipping like this till 99 floor, so this you will do almost like 50 drops, right? And then 99 it breaks, let's say. Then you go back to 97 where it did not break, so you start with 98. Okay, and you figure it out that okay, it did not break, so this is your highest floor where it did not break. But you are like almost doing 50 drops here with the first egg, okay, and then one more drop with the second egg. So you are almost ending up doing 51 drops. So this approach is also not good. I mean, skipping one floor at a time is also not a good approach in a worst case scenario. Okay. Now see, if you observe carefully, in the case of binary approach, we are having fewer drops for the first egg. Okay. See, for the first egg, how are we going? This is first floor and floor, right? So we are starting with 50, then 75, then somewhere in between, then somewhere. So we are going either this way or this way. We are going quickly to the safest floor, right? We are having fewer drops for the first egg. But when we encounter, in the worst case, when we encounter the fewer drops for the first egg, then we have to do more number of drops for the second egg. Okay. That's what we have seen, right? In the worst case, what has happened? Okay, the first egg, only one drop. Okay, you figure it out. Okay, 50th floor, it broke. Okay, it broke. Then for second egg, what has happened? We have to do 1 till 49, right? So 49 drops we have to do. So this way, if you have fewer drops for the first egg, then we are having more number of drops for the second egg. In the case of alternate or in the case of skipping one floor at a time, we are having large number of drops for the first egg, but for the second egg we only have a few drops, right? So in the case of this one, right, 1, 3, 5, 7, let's say in the worst case if it is 97, 99, so we are having almost 50 drops for first egg, okay, but for second egg it's only like one drop. Say this is 98th floor, right? So this is only one drop for your second egg. So that is the thing. In the case of binary approach, we are having fewer drops for the first egg, but we are having more number of drops for the second egg. In the case of skip one floor at a time approach, we are having large number of drops for the first egg, but very few number of drops for the second egg. So we needed a balanced approach. Okay, we needed a balanced approach, right? So how do we do that? Okay, so one solution is like skipping 10 floors at a time. Okay, let's say. So this way what has happened is, like first egg we have like almost 10 drops for your first egg, and based on the thing then we will be having around 9 drops for the second egg. Okay, this is for the first egg, this is for the second egg. Almost a balanced approach. Okay, so we are getting almost 19 drops in any case, like in the worst case, whatever the thing, whatever will be the floor, we will be doing it in 19 drops. This is lot better than what the binary or a skip one floor approach. Okay, but is that the best that we can do? Okay, or is there something that we can improve? Okay, so this approach, right? Skipping 10 floors at a time. Okay, here we are skipping constant number of. We are skipping constant number of floors each time, right? Constant number of floors each time. Okay, so these are constant number. We are skipping 10 floors at a time. So we have got around 19 drops, but can we do much better? Okay, let's study this constant skipping approach a little more detail. Okay, see, yeah. So let's take case 1 where your egg breaks at the 11th floor. Okay, let's say so for the first egg you drop from first floor, it doesn't break. Then you skip 10 floors, right? You skip 10 floors, you go to 11th floor, and here your egg breaks. Okay, so you did 2 drops for your first egg. But for the second egg, what all we need to check? We need to check between 2 to 10, right? So 2, 3, so you are doing 9 drops. So you are almost doing 11 drops, and you are figuring that out. Let's say your case 2, your egg drops at 21st floor. Okay, your egg breaks at 21st floor. Then you will be doing between 12 to 20, right? Like this. Let's say you take case 3 where your egg breaks at 31st floor. Then you will be doing like 4 drops here and the same 9 drops here, so it will be 30, right? In case of case 4, it will be like 31 and 41. So these are like 5 drops and these are again 9 drops. So it is 42. So in each case, when you are going to the higher floors for the first egg, okay, so the number of drops for the second egg is constant because we are skipping constant floors, right? But for the first egg, each time we doesn't break at a lower floor and we keep on going up direction, then your number of drops is increasing. Okay, so the problem with the above approach, okay, what is this approach? You are skipping constant number of floors. Constant number of floors. We skip same amount of floors each time. So the worst case total number increased by 1 each time the first egg doesn't break. See, here the first egg breaks, it's okay. But here the first egg doesn't break here, so the total number of drops increased by 1 here, right? So it's 11 plus 1. Now here, it's 11 plus. Now here again we are increasing by 11 plus 1 plus 1. Here again we are increasing by, okay, 1 more time. So each time the first egg doesn't break, our total number of drops increases by 1. Okay, and we need to counter that. Okay, so we need a solution to counter it. So what do we mean by we need a solution to counter it? So what we want to find out is, okay, the worst case total number of drops to decrease each time the first egg doesn't break. Okay, so we start with higher number of floors. We start with skip higher number of floors. Okay, skip higher number of floors, and each time that first egg doesn't break, okay, your total number of drops should decrease. Okay, we want a decreased thing, but not an increased thing. Okay, so how do we choose how many floors to skip the first time? Okay, so this is the important question to find out, right? So 2 things will help us to solve this problem. One is, we want to skip as few floors as possible the first time we drop an egg. So if our first egg breaks right away, we don't have a lot of floors to drop our second egg from. Okay, it can't be like you drop the first egg from, let's say, 25th floor. Okay, if it breaks here, then we have to go from 1 till 24, right? So these are the more number of drops. This is also not a good approach. So we need to skip as few floors as possible, but that should also be like each time the first egg doesn't break, then our worst case total number of drops should decrease each time. Okay, and we want to reduce the total number of floors skipping by 1 each time. Okay, we do not want to skip same number of floors each time. Okay, so with all these things, okay, so our equation will turn out to be, if we start with n is the number of floors that we skip the first time. Okay, so the second drop, if it doesn't break here, okay, if it doesn't break, then what will happen? For the second drop, our number of drops should decrease by 1. Okay. If it doesn't break here also, then it should be our total worst case total number of drops should decrease by 1 each time, right? Then it should be till like for the last case we only have one floor to split. Okay, so like that, if you go to that, we start with n number of start with skipping n number of floors, then it will be like each time we reduce by 1, so it will end up like the last exam we skip only one floor. So this will turn out to be this equation, right? So this is like sum of n numbers, it will be n into n plus 1 by 2, so this will be, and you solve the equation, it will be around 13 point, and you round it off, it will be 14, right? So 14 is your number of floors that you should skip for the first time. That is what this equation is telling us. So will this solve a problem? Let's take some considerations, right? So we skip by 14 floors for the first time, and in worst case reduce by 1 each time. Okay. So let's say in scenario 1, let's say if our highest floor where egg won't break is let's say 13, right? But we start with 14th floor and egg breaks. So we did a 1 drop for the first egg. So since egg broke here, the second egg we need to do 1 to 13, right? So these are 13 drops and this is 1 drop. So we have 14 drops here. Let's take another example where the highest floor where egg won't break is like let's say 98th floor. Okay, this is 98th floor. So in such a case we start with 14. Okay, egg doesn't break, or egg doesn't break here. Okay, so this is fine. Okay, then we go to 27th floor, egg doesn't break. We go to 37, egg doesn't break. We go to 50th floor, egg doesn't break. So we keep going, but each time we are reducing by 1 here, right? We are reducing by 1 here. Okay? So it doesn't break, it is safe, doesn't break, it does. So where here, let's say it breaks, okay? The egg breaks, the first egg breaks. So by now we did only 11 drops here, till here, okay? So now the last floor at which it doesn't break is 95, so we start from 96 to 98, okay? So we did 3 drops, okay? And so we end up being like we did 14 drops to find out the highest floor at which it doesn't. So the solution for this problem is, so you need to you require in a worst case you require 14 drops. This is the lowest possible number of drops that we can use to find the highest floor from which if you drop an egg it won't break. Okay, so this is your answer. Okay, this is one of the interesting interview problem. Okay, but it doesn't test your programming skill or anything, but it tests your mathematical and logical ability. Okay, thanks for watching.